All right, this is a Trig active question. Please get your calculator. You're going to be using it for this whole question. A particle moves in a straight line. Its displacement x meters at time t seconds is given by x of t is equal to 24 cos of 3t minus 7 sine of 3t plus 30 for t greater than 0. And it says express x of t as a single cosine function. So they're telling you that we're looking for a cosine function, and it's a cos plus a sine or cos minus a sine. So I'm going to decide that I will rewrite this in the form, maybe r is cos of, and I'm going to use this 3t plus alpha. Okay, so I'm selecting my single cosine value. I know I'm going to have a different amplitude, and I'm going to have a phase shift of alpha from this 3t that I've got. Okay, now if I'm going to go with a cos of a plus b, I'm going to need to use one of my identities. Okay, so let's start. We've got x of t is 24 3t minus 7 sine of 3t plus 30. And I have a look at my formula sheet and I see that cos of a plus b can be rewritten. So using cos of a plus b is cos a cos b minus sine a sine b. And in our case, our a is going to be our 3t and our alpha will be our b. So I can then say, okay, that we're going to let this thing that I want to create, my new equation or my new function, is going to equal r times cos of 3t cos of alpha minus sine of 3t sine of alpha. So I can therefore say that 24 cos of 3t sine 7 of 3t is going to be equal to, now be careful, look here, 24, I want my cos of 3t as my variable. So I'm going to have r cos alpha times by cos of 3t. And then I want my sine of 3t as my variable. So I'm going to have minus r sine alpha, r sine alpha sine of 3t, and that's going to be equated to my negative 7. Okay, so now we're going to equate the coefficients of cos 3t and sine 3t so that I have 24 is our cos alpha and negative 7 is negative r sine of alpha, equation 1 and equation 2. And as in our previous example, we're going to divide 2 by 1 so that we get 7 over 24 is equal to tan of alpha. Now that's not going to be an exact value, so we're going to use our calculator, and alpha is inverse tan of 7 over 24, and it's approximately 0.284, and make sure you're using radians. Okay, then we're going to substitute our angle into 1. keeping in mind we're just taking the positive value because sine and cos were both positive, and so sine, cos, and tan are all positive in quadrant 1. So r is going to be 24 over cos of 0.284. Please keep this exact. Just keep it in your calculator. Don't try and round it off. And that's equal to, not 24, 25. Okay, so now I have that 24 cos of 3t minus 7 sine of 3t is actually equal to 25 cos of 3t plus 0.284. All right. But now I've got this plus 30. So I need to add 30 on both sides. So therefore, 24 cos of 3t minus 7 sine of 3t is going to be 25 cos of 3t plus 0.284 plus 30. All right, so now we found our function in terms of a single cosine function, which is y is 25 cos of 3t plus 0.284 plus 30. All right. This thing's range is going to be 30 plus 25 and 30 minus 25 to 55. So my minimum is at x equals 5 and my maximum is at x equals 55. Okay, I think we're on to B already. So that's to find my minimum and maximum, and it wants us to find the first time these occur. So our maximum occurs when cos of 3t plus 0.284 equals 1. And cos of theta equals 1 when theta is 0, 2 pi, 4 pi. So when theta is 0 plus or minus 2k pi and k is an integer. But the first time is going to be when theta equals 0, is when theta equals 0. So 3t plus 0.284 has to equal 0. So t is negative 0.284 over 3. Oh dear. That's going to be, has to be discarded because my domain says t has to be greater than or equal to 0. So we're now looking for the next time. So we have a look and we see, okay, well, the next time is at 2 pi. So next time is when 3t plus 0.284 is equal to 2 pi. And that works out to approximately 2 seconds. Okay. And my min occurs when cos of theta's negative 1. And that's going to be at pi, 3 pi, 5 pi, etc. So theta is pi plus or minus 2k pi, where k is an integer. When theta is pi, we work it out that 3t plus 0.284 equals pi, and t is about 0.95. seconds. Okay, so our maximum displacement is 5, our minimum is 5 to the right of the origin at 0.95 seconds. So min is 5 meters to the right of the origin at 0.95 seconds, and my maximum is 55 meters to the right of the origin at 2 seconds. Okay, question 3, or C, says calculate this percentage of time during which the particle's displacement exceeds 45 meters from the origin O. Now, I've drawn this already to try and save a bit of time. This is a very long video. And basically what we're going to do is we're going to use our GDC, and we're going to sketch the function. You can see I've sketched in the line y equals 45. And a way to find the period is to just go from a maximum to a maximum or a minimum to a minimum. So from t equals 0.95 seconds to t equals 3.05 seconds is 1 cycle. So therefore, I know that my period is 2.1 seconds. And I need to figure out what period of time or what percentage of time this thing is above my 45. So I'm going to label my points. That point there is 1.69 and 45, and that point there is 2.3 and 45. So I can figure out how long that period is over there. Okay, so particle is above 45 meters from 1.69 seconds to 2.3 seconds, so around about 0.61 seconds. And I can work out that percentage of time, because 0.61 seconds out of 2.1 seconds times 100% is 29% of the time. So particle is more than 45 meters away for approximately 30% of the time.